Hello, welcome to this Rock and Talk webinar. I'm going to present a Latin American perspective on the path towards carbon neutrality in the cement and concrete industry. My name is Yury Villagrán-Zaccardi. I work at Ghent University in Belgium, and I devoted a big part of my career at LEMIT in CONICET, Argentina. The presentation I'm about to deliver is connected to a paper that we recently submitted to RILEM Technical Letters together with other Latin American colleagues. And these are Lina Rojas and Ricardo Pareja from FICEM, the Inter-American Federation of Cement. Both of them very generously contributed with statistical data to this presentation and to the paper itself. The paper also has contributions from Edgardo Irazar from the National University of the Center of Buenos Aires in Argentina, Andrés Torres from the Mexican Institute of Transport, Vanderlei John from the University of Sao Paulo in Brazil, and Jorge Tobón from the National University of Colombia. To all of them, I express my gratitude, and I also give credit for part of the content of this presentation. So when we are talking about CO2 emissions per capita, we have to be aware that Latin America is in pretty good shape. So the per capita emissions in the region are only about the emissions of Africa, and all the other regions are emitting more CO2 than Latin America as a whole, excepting for some islands in the Caribbean, such as Trinidad and Tobago and the Antilles. All the countries have a very low emission, lower than the world average. But this does not mean that the national governments in Latin America have not committed with reducing their carbon footprint. The problem is that the national targets and the path towards these targets is not going very well, and currently more efforts are necessary for almost all countries in Latin America: Argentina, Brazil, Chile, Colombia, Mexico, and I could continue with other countries. So additional efforts are necessary in the different industries. And concrete, as you might know, is a relatively sustainable material. The specific carbon footprint and embodied energy of concrete is much lower than many other materials. The problem is that we use very significant amounts of concrete, and therefore the cement and concrete industry has a very significant carbon footprint. And after all fossil fuels, the cement industry is the one that is contributing to the anthropogenic CO2 emissions. So we need to do something about it. And when we look at the Latin American market, the main cement producers and consumers are not matching completely. So here we have a conceptual map in which the size of the rectangles represents the amount of cement produced per year for each country. So the main producers are Brazil, Mexico, followed by Colombia, Peru, and Argentina, and also Venezuela. But the colors are representing the consumption per capita of cement, and we can see that some countries, for example, Venezuela, is consuming much less cement that they produce, meaning that the industry have a carbon footprint that is not capitalized by the population. So most of the cement is being exported. So in this, we had to put some attention when we consider the carbon footprint of the industry in a region where, for example, the countries on the Pacific coast many times import cements from Asia when the demand has some peaks due to the increase in the construction works. And for example, these peaks have been occurring now that the pandemic is literally fading, and we can see variations between 2020 and 2021, very significant variations, for example, for Argentina and Peru, with 24% and 40% increase in the cement demand. And also Brazil, Chile, and Colombia. We can see that for the cases of Argentina and Colombia, for example, the increase in demand is mostly for cement in bulk. And this is connected to the type of use that this cement is having in large-scale works and large projects for housing. But in other countries, Brazil, Chile, and Peru, for example, most of the increase in cement demand is in cement in bags, and this is due to the fact that it's used in applications that are not so massive, such as self-construction and real estate or private works. And these two different forms of delivery have significant implications regarding the efficiency of the use of cement. And this is something that we need to put attention also when we want to reduce the carbon footprint of the industry. Sudden increments in the level of the demand, such as the ones I'm showing here, are hardly satisfied by some supplementary cementitious materials. So when we have an increase in demand, we can easily produce more clinker, we can easily mill more limestone or natural pozzolans, but normally for blended cements that are containing slag or fly ash, it's more difficult to find the sources of these SCMs so as we can maintain the clinker factors in the same level. So peaks in the demand normally result in also in peaks in the value of the peak factor, of the clinker factor. Regarding the ratio between cement in bags and cement in bulk, when we see Latin America as a whole, we notice that the amount of cement in bags is much higher in relative terms in comparison with other regions. So we have this general trend worldwide. And for the average GDP per capita of Latin America, the amount of cement in bags should be much lower. And this is connected to the social structure that we have in Latin America, where inequality, social inequality and economical inequality is much higher than in other regions. This also is affecting the carbon footprint of the industry by increasing the demand of cement and concrete due to inefficient use of the materials. But that is when we watch the region as a whole, but in the different countries there is some contrast. We have the case of Brazil, the main producer and consumer in the region by far. And the ratio between cement in bags and in bulk is pretty similar to the average of the region. But then we have countries such as Chile, where 60% of the cement is consumed in bulk. And on the other extreme, we have countries like Guatemala, where only 20% of the cement is consumed in bags. So the approach to reduce the carbon footprint and to make more efficient use of cement and concrete should also account for the differences in the development degrees in different countries in Latin America. And this is important, as I was saying, regarding the efficiency in the use of cement and concrete, because the use of bag cement has been demonstrated not as efficient, and normally there are significant volumes of waste being produced. For bag cement, for example, we may need up to 2 times the amount of cement for the same application, in which we can apply ready-mix concrete that normally has a production of waste between 10 and 20% of the material that is actually used in the structure. similar figures to those of bagged cement we have for premixed mortar. This can be very much improved with better training of the users. But moving towards industrialization in the cement and concrete industry can effectively improve these values, this production of waste, and making better use of cement and concrete, more efficient use. So reducing waste can be achieved by improving quality control, also by optimizing mixes. There is a very recent rock and talk by Doug Hutton that is very interesting and very recommendable for making use of superplasticizers and optimizing the skeleton of aggregates so we can use less cement in mixes. Also, the systematization of operations and maintaining cleanliness in construction can help into reducing waste and the reduction of the carbon footprint of the industry. Another strategy that is very much suitable for the Latin American market is the increase in the proportion of the precast industry in the construction. So when we compare precast to on-site concrete, the first thing we notice is that we need more clinker in cement and we need more cement in concrete to produce precast elements. And this is due to the need of faster strength development than concrete on site. But on the other hand, the systematization of the production and the quality control can achieve lower levels of production of waste and more efficient use of the material, especially regarding the performance of the structures that are constructed by precast is much higher in general terms than the construction on site. Of course, some types of works will always be made on site, but when we are talking about reinforced concrete, we observe significant defects in the construction on site that are generally more difficult to avoid than in the precast industry. So incrementing the proportion of the precast industry can certainly achieve more efficient rates in the use of cement and concrete. And the same increase in efficiency can be achieved, or a similar increase in efficiency can be achieved by increasing the strength class for concrete. So let's take this example, a column made with concrete with strength class 25 megapascals. We would need half a cubic meter to resist 340 tons. But if we increase to 40 megapascals, we can reduce the volume of the column 37% and also the dead load 37%. So this means that we will need less cement for constructing the same structure, the same column, for the same purpose of resisting these 340 tons. And in Latin America, most of national regulations still contain slightly outdated values for the compressive strength of the specified compressive strength for structures, making it less efficient and not pushing the market into a more efficient use of cement and concrete, which is really needed these days. Here we can also see the effect of strength on relative economic costs. This is an estimation for Argentina, where we see that as we increase the compressive strength from 20 megapascals to 50 megapascals, of course the cost per cubic meter increases, but when we consider it per ton of load that this concrete will be resisting, we can notice a reduction in the costs. So increasing the strength level of concrete in structures is not only beneficial for sustainability, but also for economy of the construction. And here we see an investigation from de Rousseau and co-authors, in which, of course, when they design concrete, conventional or with fly ash, for a higher compressive strength, we have a larger embodied carbon per cubic meter of concrete because we need more cement. But when we compute the embodied carbon normalized by compressive strength, we observe that the lower compressive strengths are the mixes that have the largest embodied carbon. So again, this is showing how moving towards higher compressive strengths can help into achieving more efficient use of cement and concrete. Another example is in the Argentine regulation, where a very significant penalty was introduced for concrete that was produced without a quality control system. So on one hand, we will have a larger standard deviation that will separate more the mean value that we use for designing the mix from the characteristic value that is used in structural engineering, but also by increasing with the coefficient that is about 5 megapascals, and the production of concrete without quality control had proven effective in Argentina to move the industry into more industrialized ways of producing concrete and constructing structures. So by introducing this penalty, concrete that was produced without quality control was more expensive because cement content was increased to meet this target, this strength target, and then the implementation of quality control systems became more competitive in the industry. But cement content is normally decided not just due to water to cement ratio or strength, but also for having adequate workability. And when we think about the workable concrete, we imagine something like that, in which something like this, in which a mix in which we have a significant content of paste. But of course, we are very much used to produce this paste as a mix of cement and water, but we can use several other materials, especially fillers, that can fill the spaces and voids between aggregate particles and then help into achieving this the required workability without so much carbon footprint, because in fact we don't need the reactivity of the clinker for producing these workable mixes. We need the reactivity of the clinker for strength reasons. So if we can solve the particle distribution in a way that we have less voids, we will require less cement. And there's very interesting work done by the group of Van der Leyen in the last decade on the use of binder intensity and how to optimize it for compressive strength by working on the packing of particles, not only the aggregates, but also the fines. And by using fillers, they have demonstrated that we can obtain compressive strengths of 60 or even more higher strength of 60 megapascals or higher with only 250 kilograms per cubic meter of cement. And this can effectively reduce the carbon footprint of concrete, not only in Latin America, but also worldwide. In Latin America, the use of SCMs is pretty much generalized. We have the most significant mineral admixture that is used in Latin America is limestone, followed by natural pozzolans, slag, and fly ash. And since 2005, the replacement ratios of clinker in cement were maintained more or less steadily. These replacement ratios are slightly higher than in other regions, even in Europe, and the replacement ratios are not as high as in Latin America. And this is mostly thanks to the widespread availability of natural pozzolans, because this is a very reactive supplementary cementitious materials, not always, but the pozzolans that are used in cement are, and then higher percentages of clinker can be replaced in cement. Nowadays, the Latin American industry have achieved a specific emission of 808 kilograms of CO2 per ton of clinker, and due to the high replacement ratios, the emission of cement is 574 kilograms of CO2 per ton. Also, the thermal energy consumption has been improving during the last years, with more use of alternative fossil and mixed wastes, and also biomass. But of course, there's a long way to go so we can achieve carbon neutrality in 2050. When we have a look at the different SCMs that are used in different countries in Latin America, the previous cannot be generalized homogeneously for all regions. And then we have countries such as Argentina, Brazil, and Colombia, in which limestone is the main mineral mixture that is used for blending cement, followed by slag. And then we have a group of Andean countries such as Bolivia and Ecuador, in which pozzolans, natural pozzolans, are highly used, up to 30% of the total cement production. We have Mexico as a special case, in which limestone and natural pozzolans are quite evenly used, but not as in high percentages and in other countries. And here the clinker factor is slightly higher than in the rest of the region. The same happens for Peru, which has one of the highest clinker factors in the region. Chile is another special case. It's the only country where fly ash has a significant participation as SCM in cement. Maybe it's only comparable to Brazil with 2% of the total cement production. And then we have Peru and most of countries in Central America, where the most used SCM is natural pozzolan, but also a significant amount of limestone is used. So we can divide the region in several groups in which limestone, slag, and natural pozzolans are the dominant SCMs. This is based not only on the geography of the different countries, but also on the specific productive structure, whether they have a steel industry or not. We can also make a classification of the different countries according to their standards. Each country, of course, has a national standard, but this can be roughly grouped in two. A group of countries that take European standards as main reference, and these countries are normally having a prescriptive approach in which the maximum amount of supplementary cementitious materials is mentioned in the standards, and another group that is mostly based on ASTM standards and which have a performance-based approach. And in this case, there's no maximum limitation for the SCM that can be incorporated in the cement. And in these countries, we have countries such as Colombia, Ecuador, El Salvador, Guatemala, Peru, Panama. So most of Central America and also the Pacific coast in South America. But these two approaches do not correlate completely with the clinker factor we have in the different countries. So if we take, for example, the case of Peru, I was mentioning it earlier that Peru has the highest clinker factor, but still a performance-based approach. So it seems that there are other limitations to the clinker factor than the regulation itself. So with this scenario, FICEM has built a strategy towards carbon neutrality in 2050, and this is very much relying on reducing clinker factor. But for achieving a more efficient reduction of clinker factors, the segmentation of the market seems necessary. So applications of cement in ready-mix concrete and precast, of course, will not allow so significant reductions in the clinker factor as applications in bag cement and mortar, screed and others that have no significant requirements as for performance, and in which the clinker factor may have reductions up to 0.4. So this segmentation of the market would achieve would allow to achieve even lower clinker factors of the whole industry, and also the reduction in the proportion in which bag cement is used. As I was mentioned earlier, it's a rather inefficient use of cement, can also contribute with additional carbon savings. So with the scenario for 2050 is that cement demand in the region will be 227 million tons, and with an overall clinker factor of 0.51, this means we will need 115 million tons of clinker being produced and 111 million tons of SEMs being used. And this represents a 65% increase in comparison with the current consumption of SEMs of 67 million tons. So we really need to look for sources of SEMs to satisfy this future demand. And we have some promising SEMs in the region. The first of all is natural pozzolans, which is available in sufficient quantities in several countries, mostly the Andean region and also Central America. But we have some barriers for their application, and the main one is the geography, because this the location of these natural pozzolans in many cases is quite far from the centers of consumption. So this makes these natural pozzolans less competitive as supplementary cementitious materials. Calcine clay is also a possibility for almost all Latin America, and this has been already been applied in Brazil for quite some years already. Now in Argentina and Cuba we have cements with calcine clays, and there are pilot projects in Colombia and Guatemala. At the moment, the main barrier seems to be the regulation and the acceptance by users. One limitation is, for example, the color that doesn't look so gray as the conventional cement. Limestone is a mineral admixture that could increase the participation in some countries such as Bolivia, Chile, Peru, and Ecuador, where the regulation is still maintaining the level of usage quite low. Then we have a variety of small contributions from local industries. So, for example, Colombia and Chile have significant production of non-ferrous slags. Then Brazil, Uruguay, Argentina, Colombia, and Mexico could make better use of agro-industrial ashes. This, by using them in co-processing, seems a good strategy, but the the barrier here is economical, because for implementing this co-processing, there's some investment needed, and the investment needs to be made compatible with the requirements for human development in the region. And also other small contributions can be found from solid wastes, such as non-recyclable glass or construction and demolition waste, for which the supply chain needs to be improved. Then we have the case of Brazil, which is the world leader in the production of bauxite, and then a significant production of red mud is made in Brazil each year, but there's some knowledge gaps still for the application of this SEM in cementitious materials, especially for the effects in the long-term strength of concrete. So with the levers that I was explaining so far, the FICEM, the Inter-American Federation of Cement, has constructed this road to net zero emissions in 2050. And all the strategies I explained reach their maximum more or less in 2030. And from there on, only carbon capture technologies will allow to further reduce the carbon footprint of the cement and concrete industry. A problem for the Latin American market for this to implement these technologies is their costs. So moving forward into carbon capture technologies that are currently available would really increase the cost of construction in the region and reduce the competitiveness of cementitious materials. So we need to further investigate in these technologies to make them more affordable and more according to the capacities of the Latin American region. So to conclude, I would like to point out the inequalities that still persist in Latin America, and the strategies to reduce carbon emissions should take into account that the investment needs for these carbon reductions should not collide with human development needs. So in most of cases, only low-cost strategies can be applied, at least in the short term. For the reduction of clinker factors, already seem possible in some countries with more use of natural pozzolans or limestone. But we need to pay attention to the education of users in these new cements, because in the past, imperfect application of these new cements or some early pathologies early pathological signs due to bad use of new cements have brought bad reputation to them. So the market has been more resistant to incorporate new technologies due to these reasons. Quality control is an important tool for reducing carbon footprint of the concrete industry. We have to pay attention on the full compliance with strength and especially durability requirements, so we have an efficient use of cement and a reduction in the carbon footprint with more industrialized means of production. The market cementation seems as an effective strategy to further reduce clinker factors, as lower clinker factors can be used for low performance applications, and this is something that is still not happening in the market in Latin America. The proportion of bagged cement in Latin America is quite high compared to other regions, and this is connected to the social structure where there's significant amount of self-construction and informal building. So in some less developed countries in Latin America, the progress of human development and industrialization can effectively promote a reduction in the carbon footprint by more efficiently using resources. The carbon emissions reduction in the coming decades will increase the demand of SCMs by about 65%, and for these, new resources of SCMs are urgently needed to meet the sustainability goals. So with this, I conclude my presentation. I hope it was interesting for you, and I would be very happy to I will be very happy to reply your questions if you have some. Thank you.